Hi guys, we're going to look at lesson number 6 today, dividing monomials. So we've been working on multiplying for quite some time. Now we're going to work on the division piece. Okay, so we're on page 25 of your note packet, lesson number 6. So today we're going to start off pretty easy. We're just going to work on a monomial divided by a monomial. So one term divided by one term. Okay, so first step is you got to divide your coefficients. So always do the numbers in the front, divide by them. Then what you're going to do is you would subtract the exponents for each like variable. So our rule of thumb here is when we multiplied, we added our exponents. But in this case, when we're dividing, we are going to subtract our exponents. Okay? And again, it's always the top exponent minus the bottom exponent. Now this is going to be really, really important. This is going to come up a few times. You never keep a negative exponent. So for example, if you had x to the negative 2. What's going to happen is we're going to move the variable to make it positive. And by moving it, I mean we're going to actually turn it into a fraction. And that negative exponent goes into our denominator. So if I had x equals negative 2, I'm going to turn it into a fraction. Because this is really over 1. I'm going to move that x squared down. The negative's going to disappear. But almost like I flipped it. Okay, so it gets moved to your denominator. So I'll give you another example. If you had, say, x to the negative 4, this is going to be the same thing as 1 over x to the 4th. Okay? Now, if I put a coefficient in the front of that, this number is going to stay at the top. You only move this part down. Okay. All right. Let's do some examples. So I have x to the 6th divided by x to the 3rd. So again, what's easy is that my coefficients are 1 divided by 1, so that's 1. Our rule is that we take that exponent and we subtract. So my final answer would be x to the 3rd. And it's not negative, so you don't have to worry about it. Okay. All right, so same thing here. We are going to divide our coefficients. So 4 divided by 4 is, whoa, wait a second. We don't even have a variable with this. I think I made a typo. Put an x in front of those. So this is really 4x to the 6th divided by 4x to the 3rd. Must have left out the letter. So I'm going to divide 4 divided by 4. Gives me 1. X to the 6th minus 3. Which is really the same thing as x to the 3rd power. So this one here is going to be m to the negative 3 minus a negative 5. Okay, our rule is still we're subtracting those exponents. So this is the same thing as saying m to the negative 8. So because negative 3, you're just kidding, it should be positive 2. So there you go. Okay. Take a look at number 4. Negative 9 divided by 9. So if I divide these, that gets me a negative 1. And then I'm going to subtract my exponents. You really don't have to write this step. I'm just doing it now for our notes because some people might like to see that. So this is really negative 1, x to the 0. Now anytime we have anything raised to the 0 power, now if you remember this from anything raised to the 0 power is the same thing as saying 1. So we don't actually write that anymore. So it's negative 1 times 1. So your final answer is negative 1. So anything to the 0 power is 1. All right, so let's divide. So 20 divided by 4 gets me 5. And I have x to the 2 minus 5. So I'm left with 5x to the negative 3. Now this is our negative exponent rule. We cannot leave my answer like this. So I'm going to keep the 5 where it is, and I'm going to bring down my x, and I'm going to make my exponent positive. So this becomes my final answer, and I have no more negative exponents. Okay? All right. And again, guys, always start from top to bottom. So negative 2 divided by 14. If you divide that in your calculator, you're going to get a decimal. I'm going to keep it as a fraction because I think it's going to be much easier that way. So this is equal to negative 1 over 7. Okay, and your calculator will reduce it for you. X to the, well, if I subtract them, okay, so again, I have a negative exponent. So this one's a little tricky. You guys say, okay, where is this gonna go? It has to go to the bottom of my fraction. Well, if I look, I already have a fraction written here. So I'm gonna take this quantity here, and I'm just gonna bring it down to the bottom of the fraction that I already have. So instead of turning it into another fraction, which gets me negative 1 over 7 x to the third. Okay? And that's my final answer. All right, so now we got two different variables involved. Again, you only divide like variables. So I'm going to start with the a's first. So I get a to the 0 power when I subtract. And then I have b, 3 minus 3 is 0 as well. Now what we said earlier, if you look back to this example, anything to the 0 power is 1. So this is really 1 times 1. My final answer is 1. Looked way more complicated, right? All right, example number 8. So 28 divided by 7 gets me 4. Now I'm going to work with my x's. So I have x to the third power. So 5 minus 2 gets me 3. Then I'm going to subtract my y's. Again, always start at the top. 4 minus 5. That gets me a negative 1. Okay? So I have this negative exponent again. I need to get rid of it. So I know I'm going to need a fraction. So that's the only part that goes to the bottom of my fraction is that y to the 1. Everything else will then stay at the top. So the 4 stays at the top, and the x to the 3 stays at the top. Okay. Remember, at any point in the notes, you can always pause the video to catch up, okay, or go back. Why don't you go ahead and try number 9 by yourself. All right, so if I divide 26 divided by negative 13, that gets me a negative 2. X to the 0. Now careful with this one, there's an imaginary 1 there with that y. So that's really y squared when I subtract. Z to the negative 2. Now there's quite a few things going on here. I see an x to the 0 power, and I also see a term with a negative exponent. So think about what we know about each one of those. Anything to the 0 power is 1. And how to get rid of that pesky negative exponent. So I know my answer is going to have to be written as a fraction. So again, if it's not already a fraction, you got to make it a fraction. So that means my z to the now second power is going to go at the bottom. Everything else stays at the top. Now I know this thing is the same thing as 1. And 1 times any of that is going to be what it is. That's your identity rule. So I'm actually just going to have negative 2y squared left at the top. Because really, if I multiply that by 1, that would be my final answer. Okay? So that's kind of the meat of our lesson for today. All right, so let's take a look at these here. So here's a little bit harder. We'll eventually get to this level, so if you're uncomfortable with these 3 examples, don't worry about it. We're going to spend some more time practicing these. But I'm more concerned that you got what we did on page 25 for now. Okay, so we might have more than one operation. Okay, and we might have more than, now we're going to kind of be bringing in some of that multiplication piece. So when you have more than one operation that's included, we're going to use our PEMDAS, order of operations. Okay. So if I take a look at this, I got a lot going on. Can't really divide just yet because I have multiplication happening here. So I'm first going to multiply out. So let's multiply that top piece out. So that gets me 16. X to the 8th, so I'm multiplying, so I'm going to add those exponents. Then I still have 4x to the 8th. Now this problem looks just like what we just were doing. Now I can divide. So 16 divided by 4 is 4. X to the, 8 minus 8, the same thing as x to the 0 power. Again, this whole thing turns to a 1, so it's really 4 times 1. So my final answer is 4. Ooh, for number 2, we got our power rule. Okay? So I'm going to have 4 to the 4th power. So remember that power rule that we were working on a couple days ago? Then I have k to the 8th divided by 4 squared. So again, I'm applying that power rule. K to the 6, because we multiply. So I'm going to multiply these out. Again, use your calculator. So 4 to the 4th power is 256. K to the 8th divided by 16. K to the 6. Now this is really easy. Pretty sure these numbers divide nicely. 256 divided by 16, you get 16. K to the 8th minus k to the 6 is k squared. All right, go ahead and pause number 3. Give it a try. Give it a try. All right, if you're confused, that's okay. If you think you've got it. So the whole point is here is that I have a power rule when I have a fraction. That power rule is not just being applied to the top like it was over here. It's now being applied to this entire fraction. So you almost want to think of it as that 2 to the negative 2. It's kind of written that way. Okay? So when I multiply this out, I'm going to get 2 squared k to the 6 divided by 3 squared, because again, this power rule is being applied to this entire fraction. Okay, that's why there's the stars. This is a hard one. And k to the negative 4. So this is the same thing as 4k to the 6 divided by 9k to the negative 4. Now, if you tried to divide 4 divided by 9, probably came out as a decimal. Leave it as a fraction. So 4/9. Apply this here. Now careful, it's not 6 minus 4. It's 6 minus a negative 4, because those are, you subtract your exponents, which is really a positive 10. So this whole thing becomes k to the 10. So you can write it that way, or if you want, you could say 4k to the 10 divided by 9. So those are your two possible answers. You don't put k to the 10 in the denominator because it's not negative. So it either stays at the top or you can put it on the outside. If you need to, rewatch the video. If you miss something, go back, replay it. Always email me with questions or whatever you got. There is the lesson number 6 notes. Have a good day, guys.